Hello everyone. Thank you for joining with us today on Smart India Hackathon presentation from the team Hawkeyes of Rajalakshmi Institute of Technology. We are excited to present our innovative project integrating AI and IoT with light activated smart gel beads, an eco-friendly system for accurate water quality parameter analysis. Our project addresses a critical need for ensuring safe and sustainable drinking water to all rural households in the country. The main motive of this project is creating a testing product which is easily accessible and provides reliable quality analysis at an affordable cost. This device enables rural people to assess the quality of water they consume. Access to clean and safe drinking water is a fundamental necessity. However, ensuring the right chlorine levels in home water supplies can be challenging. Traditional methods of chlorine detection are often cumbersome, expensive, and not user friendly. Solution: our solution leverages light activated smart gel beads that change color in response to the chlorine levels. This provides an intuitive and visual method for detecting residual chlorine in water. We have integrated artificial intelligence to analyze the color changes of the gel beads and Internet of Things technology for real-time data transmission and monitoring. This combination ensures accurate and immediate feedback on chlorine concentrations accessible through a user-friendly interface. Our system is designed to be both affordable and easy to use for home users. The gel beads are reusable and the UV light activation process is straightforward, making the operation simple and efficient. We prioritize sustainability by using biodegradable materials and ensuring minimal energy consumption. This makes our detection process environmentally friendly and safe for household use. In the case of versatility, the product can be scaled for different water volumes and customized for various contaminants by adjusting the catalyst or the light source. This adaptability makes it suitable for diverse water quality testing needs. In addition to the chemical contaminants, our project includes solutions for detecting bacterial contamination such as E. coli. By integrating specific sensors and AI analysis, we can identify and alert users to the presence of harmful bacteria, ensuring a higher level of water safety. Innovation and uniqueness of the solution. Our solution stands out due to its innovative and unique features. By dual measurement approach, we combine chemical reaction results with electronic sensor data to enhance the specificity and accuracy of chlorine detection. This dual approach ensures more reliable readings compared to the traditional methods. By using both chemical and electronic methods to cross-check the results, we significantly reduce the chances of interference from other substances. This ensures that our chlorine detection is both precise and dependable. For the analysis, our system leverages AI to integrate data from both measurement approaches. This allows for precise chlorine level readings, providing users with accurate real-time information about their water quality. Beyond just chlorine, our system is capable of providing a thorough assessment of water quality by accounting for various contaminants. This comprehensive detection ensures that users are well informed about the overall safety and quality of their water supply. Now, I shall introduce the key technologies and components behind our water quality monitoring project. We are using C and C++ for microcontroller programming, Python for AI model training, and JavaScript for deploying the AI model. These languages ensures efficient control, analysis, and user interaction. Our framework includes the sklearn library for machine learning and the Wi-Fi library for SHA-O ESP32C3 for real-time cloud communication. For hardware, the SHA-O ESP32C3 microcontroller manages communication between sensors and the cloud. Smart beads detect chlorine levels while an OLED display provides a clean user interface. We have incorporated several sensors, a pH sensor to measure pH, alkalinity, and a TDS, a turbidity sensor to check microbial activity, a temperature sensor to observe chlorine reactions at different temperatures, and finally a conductivity sensor to assess chlorine concentration. Together, these technologies enable reliable and efficient water quality monitoring, ensuring safer water for all.
The technical implementation. It is more feasible since we are preparing our own data set with the values recorded from our lab. The data set is designed to provide the required features to predict the chlorine level as well as silver level. The key components are UV light, camera module, and the smart polymer balls. Since everything is cheap and easy to prepare, the final viable product will be cost effective, thus make everyone to afford the product. There will be 4 chambers in the device and each device process parallelly. Therefore, the operation time can be minimized. Microvalves will be present inside the device to process the water in each chamber. The proposed revenue model is product-based model. Even though we have the theoretical idea of processing these into a model, the following challenges might be tough to encounter. They are integration complexity, such as handling the microvalves, data accuracy and reliability, since the limitation to temperature on the chemical reactions, system scalability, making it into a compact module is quite complicated, maintenance and support, to be assured that the sensors can be replaceable, security, since we are handling with the chemical, it has to be properly disposed. The potential impact on the target audience are comprehensive water quality monitoring, ensuring all the important parameters of water are at safe level. Real-time data collection, the data are processed in real time and updated to cloud. AI-driven insights. Here we go. The whole model is driven by the AI model to predict parameters of the water and taking decisions. Scalability. This miniature product can be used for all the types of water, thus increases the compatibility of the system. Energy efficiency. The Shower ESP32C3 module can operate deep mode when the board is not used, thus makes it much more easier to handle the power requirement. Data sharing. The abnormality in water parameters in particular areas can identified and can be informed sooner to the government. The benefits for the user will be cost effective, sustainable product with easily chargeable module. The health and safety of the user can improve by ensuring the water is safe. The load of human works is drastically reduced by making it AI driven. The module will be user-friendly and the performance and water parameters can be viewed in the module itself, also uploaded to the cloud. We have researched enough research papers for the theoretical proof of concept for the product. We are excited about the potential impact of our project and confident that our cost-effective and innovation solution will contribute significantly to ensuring safer water quality. Thank you once again for the opportunity to share our work with you all.